we're going to go ahead and get started. We're going to look at question number 6. And these are out of 1, 4. And the 3 ways that we can solve the questions out of 1, 4 is either by zero factor, quadratic formula, or the square root property. Question 6 is the quadratic formula. So what we've got on question 6 is we've got x plus 2 times x minus 7 equals 9. So this is what we've got to start with here. Now before we can factor, before we can use the quadratic formula, before we can even begin to solve this, we have to get rid of the parentheses. So the parentheses have to be gone. And we do that by simply foiling. So we're going to go ahead and FOIL this out over here. And that's going to give you, when we distribute through, we'll draw our arrows here. First times first is x times x, so that is a x squared. Outside and outside, that's a minus 7x. Inside is a positive 2x. And last is a minus 14. And that gives you then x squared minus 5x minus 14. Is everyone okay with that so far? So the first thing we have to always do is if we have parentheses or fractions or decimals, we get rid of them. Now, when we want to solve it using either the zero factor or the quadratic formula, it has to be set to 0. So let's go ahead and move this 9 over. And that's going to set it to 0. So now we have x squared. We have a minus 5x. And we have a minus 14 minus 9. That makes it then a minus 23, doesn't it? Always double check if ever in doubt. You do not want to make a mistake because you added incorrectly. So that's going to give us our minus 23 there. Now, when we're at this step, it says use the quadratic formula. Now, in order to use the quadratic formula, we have to make sure it's in the correct order. First off, is it been set to 0? Yes. Does it go down in powers? Does it go x squared, x, and then the number? Yes. If there's no number in front of the x squared, we're going to put a 1 here. The number in front of your x squared is your a, so that's a 1 in this case. The number in front of the x, that's your b. And that's a negative 5 in this case. And then c is the number on the end. And that's going to be that minus 23. I always just like to circle negatives. That way we don't accidentally lose one. So that's our a, our b, and our c. Now we want to apply our quadratic formula. So what I always do is I write up the formula. That way we have it right in front of us to look at. And our quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's what we generally do is we just write up our formula and then we fill it in. So let's go ahead and fill it in. See what we've got. Watch out again for double negatives. If there's a mistake, a lot of times it's in that double negative. So we have a minus 5, and we have a plus or minus, and then we have the square root of minus 5 squared minus 4 times a, which is 1, times c, which is a minus 23, and that's all going to be over 2 times 1. Is everyone comfortable with how I'm plugging the numbers in? And again, take your time. The quadratic formula is not difficult. However, it is easy to make a mistake. The double negative here makes that positive. We bring down the plus or minus. We bring down our square root. And what's going to go down below? It's 2 times 1. Well, that's a 2. Now we work with our discriminant. And the discriminant is what's underneath that root. And in this case, it's minus 5 squared minus 4 times 1 times a minus 23. This is where the most commonly made mistakes are made. When we square that negative 5, it becomes a positive 25. Now, when we look at this part here on the end, we look at how many negatives we have. And a negative times another negative makes it then a positive. So that piece is going to be positive. And then we just multiply our 4 times our 23. That comes out to be a 92. And then we can add them together. And that gives you 117. Now at this point we may or may not be done, because that square root of 117 may or may not break down. First thing we always do, even though we can tell it's not, is check to make sure it's not a perfect square. And it is not a perfect square. So now we're going to try to factor 117 down. 3 goes in there. And then we've got a 3 and a 39. Let's see if we can go further. Yep, we can. 3 and 13. And 13 is a prime number. It can't be broken down. But we do have a pair. And we have a pair of 3's. So I am now going to rewrite this as 5 plus or minus 3, because the 3's came out. Okay, they're gone. What's left over that didn't pair up? 13 over 2. Now you could leave it like this, but I usually break it up. I usually break it up into my 2 separate parts. So if I broke it up into my 2 separate parts, what would they be? We've got 5 over 2. So this would be an acceptable answer here. I usually break it down and reduce as much as possible. And then when I write my answer, I get the 2 parts, the plus case and the minus case, because I want you to make sure you understand there are 2 solutions. Because in the past, if I just put the plus or minus, inevitably someone doesn't remember that there are actually 2 solutions. So I break it up, I rewrite it into its 2 separate pieces, and then I get out my 2 solutions. And the textbook stops right here. That's okay. I, though, really like to take it all the way down so it reinforces that you actually have 2 solutions. Not just one, but you have 2 of them. So this would be acceptable here too, but I like to bring them down a little bit further. Is everyone all right with that? That was a little bit tricky because you had to break up that 117. We had to FOIL it first. It's just easy to make a sign error more than anything else. Question number 7. We covered one like question number 7 last time when we looked at these. And this one has fractions. Now, one thing we never, ever want to do is we never, ever want to put fractions inside of the quadratic formula. Because the quadratic formula is already complicated enough, and so we never want to use decimals or fractions in it, unless they're unavoidable. In this case, we can clearly and easily avoid this by multiplying everything by what? Does anyone have any idea? Does anyone remember what we would use here? Okay, I want to clear out my fractions. Does anyone know what I would multiply all of this by? 2. Not 2. What do we have down here? Okay, let's look at our denominators. So we have an x, right? And we have an x squared. Now, when we want to clear out our fractions, we want to make sure that we multiply it by something that will make everything go away. And we do that by looking at our largest exponent. So what's our largest exponent? It's x squared, right? So we're not going to multiply it by 2, but we're going to multiply it by x squared. And when I multiply it all by x squared, that's going to clear out all the fractions, okay, because the x squared is down below. So let's see what happens when I do that. Well, I get a 3x squared. Now, what happens with the x and the x squared here? Well, an x squared and that x, one of those can cancel, and that's going to leave you with a minus 10x. And then the last piece is x squared, and it's going to cancel with this x squared down below, and that's going to leave you with a minus 4. Is everyone okay with how I cleared that out? So multiplied all by x squared. That got rid of all of our fractions. Now we're going to go ahead and rewrite this in the correct order. So I'm going to move 10x over and 4. And that leaves me then with the 3x squared. We've got a positive 10x and a positive 4, and that equals 0. And we can now go ahead and find our a, b, and our c. So what are our values for a, b, and c going to be? Well, a is the number in front, so a is 3. B is the part with the x, so b is 10. And c is 4 on the end. So a, b, and c. It's in the correct order. We've got our pieces. Now we can apply our quadratic formula. So with our formula, x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And we plug our values in. So we have a minus 10. We have a plus or minus again. The square root of 10 squared minus 4 times 3 times 4 all over 2 times 3. Now we're going to break this down. We don't have to worry about any double negatives, so that minus 10 comes down. We're going to still have the plus or minus. We're going to leave our square root there. And 2 times 3 makes it a 6. Next, we focus on what's underneath our square root, and that's our discriminant. And what is our discriminant? Well, the discriminant is 10 squared minus 4 times 3 times 4. And this is going to bring back a little bit from what we learned about from 1.3. If this discriminant comes out to be a negative number, that means it's going to be imaginary because negatives underneath that root come out as imaginary. So 10 squared is 100. A single negative makes that stay negative. And we've got 4 times 3 times 4, and that's 48. And then 100 minus that 48. In this case, it still stays positive, and that makes it then a 52. Now, if it was a negative 52, an I would come out with it, right? But ours is not negative. Ours stayed positive here. We need to break up that 52 if possible. 52 is an even number, so let's see if 4 will go in there. We could use 4 and 13, and then 4 is 2 and 2. So rewriting, we now have minus 10 plus or minus 2 square root of 13 over 6. Is everyone comfortable with how to break up these roots? We see what we're doing here. What we do is we just break them down. If it If it's negative at the end and I comes out with it, either way, we break it down by looking for pairs. We want pairs because pairs will come out as 1 because that's a square. Now we break it up as minus 6 over 10 plus or minus 2 square root of 13 over 6. And can we break this down? We can, because minus 10 over 6, well, that's going to reduce down to a minus 5/3. That 2 and that 6 can cancel. That leaves you with the square root of 13 over 3 as well. Because the 2 and the 6 could reduce here, and 10 and 6 reduces to 5/3 here. Go ahead and get your 2 solutions. So we have minus 5/3 plus the square root of 13 over 3, and we have minus 5/3 minus the square root of 13 over 3. Okay, so that takes care of question number number 7. Question 8, similar to one we did last time, just different fractions is all. I'll leave this up here for a moment. Question 8, we still have to clear the fractions again. But this one has numbers below. I think the one that I gave you as an example, we multiplied by 3. This one we're going to have to multiply by 9. So in this case, we want to clear out our fractions. And this is going to be exactly the same as any of the others we've done. So we want to go ahead and clear out, hope that makes it a little bit easier to see. We want to go ahead and clear out the fractions. And when we look at this, we look at our denominators. So we have a denominator of a 3, and we have a denominator of a 9. And if I multiply it all by 9, that's going to remove all the fractions. So that's my second step here, is to go ahead and multiply it all by 9. And I think I may have missed the equal sign here. We should have an equal sign there at that minus 1. So it should be an equal sign right after that minus 4/3 x. Yep, everything else looks right. So now we're going to go ahead and clear our fractions. The 9's cancel, and that leaves you with a 4x squared. 9 divided by 3 is a 3. 3 times a negative 4, well, that makes it a negative 12x. And we've got our equal sign. 9 times negative 1, well, that's a negative 9. We're going to go ahead and add 9 to both sides, and that gives you now 4x squared minus 12x plus 9 equals 0. I'm going to use this problem to illustrate something else. No matter which way you choose to work out this question, you're going to get the same result. Now, we could use the quadratic formula, which we will. Okay? But we could also look at this as a perfect square trinomial, because we looked at those earlier last week. What do we know about 4, and what do we know about 9? Are they perfect squares? Yeah, because 4 is 2 what? Squared, and 9 is 3 squared. Negative in the middle, and I can actually go ahead and break this down into 2x, bring down your negative, minus 3, quantity squared. Because I noticed that it's a perfect square trinomial. Now, what would my two solutions be? Well, they're going to be the same because this is squared, so we only really get one solution. So this has one solution. And that one solution is 2x minus 3 equals 0. So 2x equals 3. So x equals 3 halves. Now, if we use the quadratic formula, we will get the exact same result. Right? All these methods give you the same result. We can't use the square root property because that's a little bit different, but we can use, in this case, the fact this is a perfect square trinomial. Now, let's see if we use the quadratic formula, we get the same answer. So that was with zero factor. Now let's use the quadratic formula. So if I want to apply the quadratic formula, I've got 4x squared, I've got a minus 12x, and a plus 9 equals 0. And that means now my a should be what? Can someone tell me what the a will be? If I use the quadratic formula, what's my a? 4. Okay, what's the b? Negative 12. And what's the c? 9. Okay, now I should end up with this. And we also know that the only way that we can get one solution is if our discriminant is 0. Remember that? Because that's what came out of those questions 13 through 16. Is you look at the sign of the discriminant, and that can tell you how many and what type of solutions you have. So if I apply the quadratic formula, let's write it up. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. If I try to apply that, what do we get? Well, we get a negative of a negative 12. Then we have a plus or minus. We have a negative 12 squared minus 4 times 4 times 9. And that's all going to be over now 2 times 4. Now, eventually, we're going to get this 3 halves. It's a lot more work to use the quadratic formula, but the quadratic formula solves everything. The only reason we could use the zero factor is because I noticed, just by looking ahead of time, this is a perfect square trinomial. Either way you solve it, you're going to get the same result. The quadratic formula works every single time. The other methods, they work only in certain cases. However, the quadratic formula is usually quite a bit more work than the others. So now let's go ahead and clean this up a bit. Double negative at the 12. That's going to make that a positive. We've got our plus or minus. 2 times 4 makes it an 8. We still have our square root. And let's look at our discriminant. Your discriminant is a minus 12 squared minus 4 times 4 times 9. So 12 squared is 144. 1 negative keeps that negative. 4 times 9 is 16. 4 times 4 is 16. Times 9 makes it 144, and that gives you then a 0. Okay. Square root of 0 is 0. We don't even need to write it. So now we've got plus or minus, that goes away. 12 over 8. And what does 12 over 8 reduce down to? 12 over 8 reduces down to the same what? The same 3 halves. So notice, either way that you do it, you get the same result. In many cases, though, your quadratic formula might be the only way you can solve it. Zero factor works sometimes, if they're whole numbers. They might be a perfect square. If they are, use a perfect square trinomial method. If they're not, or you're unsure of yourself, use the quadratic formula. But other methods are generally a little bit faster. You saw how much quicker the zero factor was when I realized that we had a perfect square trinomial. And I just kind of want to point that out, that no matter what method you use, you're going to get the same result. So if you see something that's zero factor and you really don't feel comfortable with zero factor, you really have a hard time with zero factor, you can use a quadratic formula. You'll get the same result. It just takes you a lot longer. Even though the directions on your exam, when you take your exam, might say use the quadratic formula, I don't care if you use zero factor. Or if they say use zero factor and use the quadratic formula, that's okay too, as long as you get the correct answer. Because all the methods work in one way or another. So that was question number 8. We've got a few more to look at. We're going to look at 13 next, and then end with 18. Now, 13, we are not going to be solving this. We are going to be using the discriminant to determine the number and the type of solutions that we're going to encounter. So let's look now at 1.4, page 138. When we work at our discriminant, this is going to tell us how many solutions that we have and what type these solutions are. Now, why would you want to do this? Well, maybe you're trying to model something in the real world, and you want to make sure that your equation at least makes sense. And so if I was working on something, let's say with time, and if I was working on something with time, I know time cannot be an imaginary number. It has to be only a real number. So I could actually check my discriminant, and if my discriminant came out negative, I would already know that that formula that I was going to use will not work. I need to come up with a different one without solving the entire problem. I could say, that doesn't make sense at all. I need to come up with a different formula, or it's not going to have a solution if we're working on something with time, which is what we're going to be doing later on today in 1.5 if we have time. But sometimes it might be beneficial to, instead of working it out completely, just check ahead of time and see, what am I going to expect? Is that going to work with my situation, the application I'm working through? So we need to use that table, and we need to remember what our discriminant is. Well, our discriminant is everything that's underneath the root, so that is b squared minus 4ac. So that is your discriminant. Now, on question 13, we have to make sure that it is ready to go into the quadratic formula. So to make sure it's ready to go in the quadratic formula, all of it needs to be moved to the left, such as 0, and we need to make sure that all of our powers are in order. So I'm going to go ahead and move that 4z over, and I'm going to make sure that it's in the correct order. So that's 7z squared, and then we have a 4z plus 6, and that equals now 0. So it is ready for the quadratic formula. We're not going to use the quadratic formula. We just want to determine the number and the types of solutions. So quickly here, A is 7, B is 4, C is 6. It's in the correct order. Now let's work out our discriminant. So again, that is b squared minus 4ac. So that is 4 squared minus 4 times 7 times 6. And that's 16. 1 negative makes it stay negative. And 4 times 7, that's a 28. Times 6 more makes it 168. And 16 minus 168, well, that's a negative again. Stays negative, so that's a minus 152. Now, what do we know? 152 is a negative number in this case. So we go back to our table on page 138. If it's negative, that means an I is going to come out with it. So that means looking at our table, it is negative. So we have 2, and they're going to be non-real complex solutions. Okay, so 2 non-real complex solutions because of the fact that that was negative. We don't even care if it's a perfect square or not. If it's negative, 2 non-real complex.
That's all you want.
Yep, and that's all I want. Yep, we don't have to actually solve this one out. So for 13 through 16, you do not completely solve them. All you have to do is set them to 0. Make sure they're in the right order. Work with your discriminant. Use the chart on page 138. I'll write that down here. Page 138 has the chart. So use that chart on page 138. If you look at it, it's negative. So you have 2, and they are non-real complex solutions. The last one that we asked about before we take a break is going to be question 18. And question 18 is x squared equals 8. Sometimes students may try to make this more difficult than what it really needs to be. So, what method am I going to use? Well, I am going to apply the square root property. Why? Because it's a square by itself on the left-hand side. So the square is by itself, or it's a quantity squared on the left, and I can get rid of a square by using the opposite. The opposite of a square is a square root, and whenever I take a square root, I always have to make sure that I add in a plus or minus. Now, 8 will break down, because 8 breaks down into 2 and 4, and then the 4 breaks down into 2 and 2. So a pair of 2's is going to come out as a single 2, and then those are paired up, but that one is unpaired, so it goes in the root. And I always like to write out my 2 separate solutions. So they would be 2 squared of 2 for one, and minus 2 squared of 2 for the other. So there's your 2 solutions. 2 squared of 2 and minus 2 square root of 2. Let's go ahead now and take a short break, and we will meet back here at, let's say, 9:35.